Good morning all of you. I am Prakash Bhadane, Dr. Prakash Bhadane. I am going to deliver the lecture on second topic of quantum mechanics, that is equation of Schrödinger or Schrödinger wave equation. In previous lecture we have discussed Schrödinger time dependent wave equation. Now in this lecture we will focus on time independent Schrödinger wave equation. Time dependent and time independent equations both are realistic equations. These are the basic quantum equations. Time independent equation applicable for the small things or realistic things, while time dependent equation is applicable for imaginary things or large scale things. So we will focus on only time in this topic. We will focus on only time independent Schrödinger wave equation. So time independent Schrödinger wave equation. For deriving the time independent wave equation, we must know the time dependent Schrödinger wave equation. And as per our previous discussion, everybody is well known, everybody is familiar with time dependent wave equation. That equation is minus h cross square upon 2m d square psi upon dx square plus v psi is equal to I h cross d psi upon dt. This was the last equation, and that equation is called as Schrödinger time dependent equations. We have derived this equation from the wave function. That wave function was psi is the x and function of t, which is equal to a e raised to I inside the bracket kx minus omega t. Equation number 2. In this wave function, size depends on x as well as size depends on t, but we want only the condition. That condition consists size depends on x but it does not depends on t. So we can write the equation 2 like this way: psi is the function of x is equal to a e raised to I kx minus omega t is there. So we can't consider omega t because wave phase depends on t. So t parameter is 0. So omega into 0, this is equal to 0. So finally the equation becomes 3, which is psi is the function of x is equal to a e raised to I kx. But we know that k is equal to p upon h cross. So we can write here psi is the function of x into a e raised to I upon h cross into px. Equation number 4. Say we can put here the value of k, which is p upon h cross. We had already derived this relation for k in a previous topic. So we can use directly that value here. So finally psi x is equal to a e raised to I h cross px. Equation number 4. Differentiate this equation with respect to x. So d psi upon dx. Why with respect to x? Because it depends on only x. The psi is not depends on t. Hence we can differentiate this equation with respect to x like this way: dsi upon dx is equal to a e raised to I upon h cross. A is constant, so outside the constant, differentiation of e raised to I upon h cross px is same. So you can write that as it is into differentiation of this whole quantity bracket, that is equal to I upon h cross differentiation of px. So p is constant, take outside the bracket. So p into dx upon dx is equal to 1. Equation number 5. Again differentiate this equation with respect to x. So this equation becomes d square psi upon dx square is equal to a e raised to I upon h cross. We know that law of differentiation by using the same concept, I upon h cross px into I upon h cross as it is into p. Differentiation of this bracket, again differentiation of this bracket is equal to I upon h cross as it is I upon h cross into px, differentiation of px, differentiation of dx upon dx is equal to 1, therefore again p. So next we can write this equation in this way, d square psi upon dx square is equal to a e raised to I upon h cross px. This value is equivalent to the equation of 4. So we can write there psi of x into I square, h cross into h cross square, p into p square. Hence I square upon h cross square into p square. Therefore d square psi upon dx square is equal to I square is minus 1, so minus p square upon h cross square into psi x. In terms of p square psi, we can write p square psi is equal to minus h cross square on this side, so minus h cross square into d square psi upon dx square. This is equation number 6. This equation is a equation for p momentum for the particles, means along the x direction, because psi is a function of x. Now as per the total energy relation, we know that total energy relation E is equal to kinetic energy p square upon twice m plus potential energy. Now multiplying on both sides of this equation with psi, then E psi is equal to p square psi upon 2m plus v psi. Equation number 7. In equation number 7, p square psi is equal to, as per our previous derivation, we know that minus h cross square d square psi upon dx square. Put this value of equation 6 in equation number 7. Then equation number 7 becomes E psi is the function of x is equal to p square psi is minus h cross square d square psi upon dx square. Hence minus h cross square upon 2m as it is, d square psi is the function of x upon dx square plus v is the function of psi x. Observe this equation carefully. Equation number 8. Observe this equation. In this equation, psi is the only function of x. In this side, psi is also function of x. Psi is a function of x, means there is no t term exists. If there is no t term, means this equation is totally directional dependent and time independent, because in this equation there is no term for t. So we can locate, we can describe the probable position of the subatomic particles in a particular direction without applying the time factor. Means we can measure the values of or the position of the probable position of the electron in a particular direction. Simultaneously we can also measure the available energy levels for that electrons, that subatomic particles in the x direction. So this last one equation is called as time independent Schrodinger wave equation, because it describes position dependent, direction dependent nature and time free nature of the propagation of subatomic particles, atomic particles or material wave in the particular direction. Similarly, same equation we can write in 3-dimensional term also, that is d square psi upon dx square plus d square psi upon dy square plus d square psi upon dz square, and at the end the equation like this way, minus h cross square twice m del square psi plus v psi is equal to E psi, where psi is the function of x, y and z. So, this last one equation is called as Schrödinger time independent wave equation in three dimensional way. So, at this point we learn two concepts. First is time dependent and second is time independent Schrödinger wave equation. Now, the next point is that what are the applications of these equations. So, by using this equation we can calculate the eigenvalues and eigenfunction for different cases like free particle, particle in a box, particle in a well, particle in one dimensional well, particle in a three dimensional well, particle in a pinna model, particles in a tunnel and so on. So, these equations are very important for calculating the different values of energies with respect to the functions. Let us describe one applications of Schrödinger wave equation here in detail. That application is Schrödinger equations is useful for calculating the eigenvalues for the particle in an infinity well in one dimensional or one dimensional infinite well. One dimensional infinite well like this way we can represent here. If x is equal to 0 is the starting point of that well and x is equal to L is the end point of that well. This well having the infinite height, it has the infinite height, due to that the electron cannot or subatomic particles cannot jump from outside. So, the electron can be available inside the well. If this is the electron available inside the well, then from this nature of the diagram we can write here three body conditions and that are called as boundary conditions for the particle which is trapped inside the infinite height well. So, electron is trapped inside the well, height is infinite, means the existence of this electron outside the well is equal to 0. Existence of this electron outside the well on this side is also 0, means electron can move in between x to xl. Here no time parameter we applied for the calculating the system, therefore we can call time independent Schrödinger wave equation, and that time independent Schrödinger wave equation is minus h cross square upon 2m d square psi upon dx square plus v psi is equal to E psi, where psi is the function of x. It depends on only one direction because it is the one dimensional system. So, this equation is useful for the calculating the eigenvalues of the electron which is trapped in a well. Here we can write three conditions. First condition, if the electron is trapped inside the well, means it can't jump outside the well, it can move from x to xl, therefore the potential energy of this electron cannot change. So, for our purpose we will assume the potential energy of the electron is equal to 0. If the potential energy is equal to 0, where in between the well, means if the particle in the range of x is greater than 0 and x is less than or equal to 0. So, first condition is we can write here x is equal to or greater than 0 and x is less than or equal to L. In between this range the value of potential energy V is equal to 0. Now, equation 1 becomes, for this condition, this is the first boundary condition, equation 1 becomes minus h cross square upon 2m into d square psi upon dx square plus v is equal to 0 means 0 into psi is equal to e psi. Therefore, this equation finally minus h cross square upon 2m d square psi upon dx square is equal to e psi. This is the differential equation. We can rearrange this equation again like this way, d square psi upon dx square is equal to minus 2m upon h cross square e psi. This whole value is equal to the sum constant and that constant is equal to k square. So, this equation becomes d square psi upon dx square is equal to k square psi, where k square is equal to minus 2m upon h cross square into e. So, k square psi. Finally, d square psi upon dx square minus k square psi is equal to 0. Equation number 2. See, in this equation, psi is the function of x. First part is derivative, second is as it is equal to 0, means this is nothing but the differential equation. So, by considering first boundary condition, we can write here this equation. Now, the solution of equation 2 is, psi is the function of x is equal to a sin kx plus b sin cos kx. By using the mathematical tool, we can find the value of solution of this equation, differential equation, and that solution is psi of x is equal to a sin kx plus b cos kx, where a and b are the constants. So, by using the first boundary condition, we got the relation, we got the solution of this differential equation. Now, second, from the diagram, we can write the second boundary condition, x is equal to 0. Observe this diagram, if x is equal to 0, then at the wall there is no chance to exit the electron or exist the electron. Therefore, the value of potential energy on the wall or outside the wall is equal to infinity. If there is no electrons, means the wave function at the wall is equal to 0. Similarly, x is equal to L. If x is equal to L, again at that point the value of potential is equal to infinity, and hence the wave function value is equal to 0, because there is no existence of electron, hence there is no wave function, because wave function represent the existence or actual probable location of the electron. There is no electron means probability of finding the electron over the wall is equal to 0. Means here we can write two boundary condition, x is equal to x is equal to 0, and second one is x is equal to L. X is equal to 0, first boundary condition. At x is equal to 0, we know that psi is equal to 0. Now, from the equation number 3, we can write the equation number 3 for this condition. So, the equation number 3 becomes psi is equal to 0, a sin k x, value of x is 0. So, 0 plus b cos k 0. 0 into a sin kx, kx into 0, 0. So, sin 0 is 0 plus b cos kx, kx into 0, cos 0 is 1. So, b. So, 0 is equal to, therefore, 0 plus b. Therefore, b is equal to 0. So, one constant is equal to 0 here. B is equal to 0 means B does not exist. So B is equal to 0. So from the condition second, x is equal to 0, boundary condition x is equal to 0, we got the value of B is equal to 0. Now by putting the value of boundary condition x is equal to L, the equation 3 becomes psi is equal to 0. If psi is equal to 0 means 0 is equal to A sin k x, value of x is L, so KL plus B cos kx, so instead of x there is a L. But from this equation, equation number 4, we know that the value of B is equal to 0, hence this equation becomes 0 is equal to A sin KL plus value of B is equal to 0, 0 into cos KL, 0. Therefore, A sin KL finally is equal to 0. This is equation number 5. See, in this equation A is a constant. As per our discussion, A and B are constant. If B is equal to 0, then A is not equal to 0. B is equal to 0, then A is not equal to 0. Means A is not equal to 0 means this equation A is not 0. So which term is 0? Sin KL is equal to 0. Here K is not 0, L is not 0 means whole sign must be 0, not this KL is equal to 0. Therefore, we know that sine of 0, we can't use 0, here we can use pi is equal to 0. Sine 2 pi is equal to 0, sine 3 pi is equal to 0, sine 4 pi is equal to 0, hence finally sine n pi is equal to 0. Compare equation 5 with this new equation, then we can write KL is equal to n pi. Equation number 6. But we know that K square is equal to minus 2me upon h cross square. Put this value in this equation. So we can't directly put here. Take the square on both sides of equation 6. So K square L square is equal to n square pi square. We know that K square is equal to minus 2me upon h cross square into L square. Sorry, not a minus, plus sign is there. 2me upon h cross square into L square is equal to n square pi square. Next, we can write here in terms of E the same equation. E is equal to h cross square on this side, h cross square n square pi square upon this 2m L square, 2m L square. But we know that h cross is equal to h upon 2 pi. Therefore, h cross square is equal to h square upon 4 pi square. Put this value in this equation, then this equation is called as E. Finally, E is equal to h square n square pi square upon 4 into 2 8 m L square into pi square. Pi square get cancelled. Finally, E is equal to h square n square upon 8 m L square. This equation gives us the available energy level for the electron in this well. Therefore, this equation is called as eigen wave equation or eigen energy equation in the particle trapped in a box. So, thanks.